Today we'll be starting with the third day of your online faculty development program on machine learning using Python. The speaker for the day is Dr. Pooja Sapra. She's been associated with Parul University as an associate professor. It is in Vadodara. She has worked with many different organizations, to name a few, like North Cap University, Netaji Subhash Institute, with World College of Technology and Management as head of computer science department, and has reviewed many Scopus Index journals also. Welcome, ma'am. Welcome to the session.
Thank you so much.
You can start with your session, ma'am.
Okay, just give me a minute. I'm just sharing my slides, right? Okay, is my screen visible to all? Can you see my PPT?
Yes, ma'am, it's visible.
Okay. So, a very good morning to all of you. Thank you so much for giving me opportunity to be the part of this wonderful FDP. Thank you, Sonia ma'am, for inviting me. And I hope I am audible clearly. And
yes, you're audible.
So I guess there is some network issue. Should I close my video and then we can start?
Yes, ma'am. Yes, ma'am. The screen is freezed, ma'am, at the moment.
Okay. I guess there is some network issue. Okay. So I'm just putting my camera off and starting with the presentation. Right? So aim of this FDP is, as we all know, we want to learn machine learning with Python. We want to learn how to make a machine learn with the help of Python, right? What we have learned so far is what is machine learning, types of machine learning, basic Python commands we have done, important libraries of Python, NumPy and Pandas, and steps of machine learning. I hope according to schedule, we have learned all these things, right? What would be the agenda for today? Please support me because I want to make you learn many things, and that includes machine learning, very brief, supervised machine learning, regression kya hai, classification, logical regression, simple linear regression, naive Bayes algorithm, SVM, KNN, so a long list, right? I hope we all would be doing it, and let's see. I'm trying to cover all these points, right? Before we go further, I would be sharing this drive link with you and would request all of you to open this drive link because this link has all the data that you would be requiring, right? So just a minute, I'm sharing this link with you. Chat is disabled, I guess. Sonia ma'am, can we enable the chat?
Ma'am, chat cannot be enabled. You just share it with me. I'll share it in the WhatsApp group.
Okay. So I'm sharing this link with you.
Yes, ma'am.
Okay, Sonia ma'am, give me a minute. I'll share it with you.
Yes, sure.
Right? And we can start with other things till the time this link would be shared and you can all explore it, right? Now, coming to the point where we were talking and we have seen this particular diagram many a times. This diagram says artificial intelligence and subset of that is machine learning and subset of that is deep learning. What it means actually? It means actually we want to achieve AI. I want to achieve AI means I want a system that will work like a human being. And to achieve that AI, I would be requiring some means to achieve that, right? And what are those means and ways? Those means and ways are machine learning. And when I talk about neural network kind of thing, that would be deep learning. So I can say that to achieve AI, I require machine learning and deep learning, right? So this diagram, I am just explaining with the perspective what I want now to learn, right? Next thing that we talk about is what is difference between traditional programming and machine learning. See, in the traditional programming, what happens, we are always given a program, we give input, and finally we get the output, right? We give input, we get output because function is given to us. For example, let me take an example over here. Suppose I want to calculate the factorial of a number. So I would be given a number x equal to 5. I want to find out factorial, maybe that would be in y, right? And for this purpose, I would use a function fact or a program fact that would be written by me, right? So I am having a program, I am having input, and I would like to find out output. This is my traditional programming. But what happens in case of machine learning? In case of machine learning, I have been given input, I have been given output. I want computer or my system to learn from this set of input and output and give me a function so that, now listen to this line very carefully, give me a function so that whatever input we give next, it should be able to give me output, right? I'm repeating this point. In case of machine learning, we are given input, we are given output, we want to find out the function. And once we are able to achieve this function, once we are able to find this function, it would be easy for me to give some input, or after that, we would be able to find the output. And this is what machine learning is for all of us, right? So I'm going for the mathematical equation. We just discussed f is a factorial, x is the number whose factorial we want to find out, and y is would be the result, right? So this equation we all are familiar with, y is equal to fx. Now y is equal to fx. In this particular case, let us see what is f. F is a function, x is independent variable because I want to find out factorial. So I would be giving individually x, the values of x, 5, 4, 3, 2, 7, whatever value I want to find out, whatever factorial I want to find out, that number would be given, right? Now, y is result because it is dependent on the variable x. So this would be called as dependent variable. So till now we have three things we have understood. One is called what is function, second is called what is independent variable, and third is called what is dependent variable. And with this, we know that what is traditional programming and what is machine learning. Traditional programming, in this case, we give data and program to the computer and receive the output. In this, we give data, means input, and output to the computer, and we get a function or a program which help us to learn more, which help us to predict more. I hope till this point we are all okay with it, right? So next thing is, when I talk about machine learning, the variables x and y, we talked about it, y is equal to fx, right? So variables x and y, they are called as basically data set. Now, x that we were saying, it is independent variable, that would be called as feature, and y that is dependent variable, that would be called as label. So now we understand two more terms, what are features and what are labels. Features means the variables which are independent. Labels means the variables which are dependent variables. So we must know what is data set, what is feature, and what is label. Now, as I discussed, in case of machine learning, and basically in case of supervised machine learning, because our agenda is supervised machine learning, in case of supervised machine learning, we would be given x and y. This is what we talked about when we were talking about this equation. We said this would be given, this would be given, and we would find this. We would find f. So given the value of x and y, we find f. This is called as training of the model. Again, another new term that is called training of the model. Next is, when we have the value of this f, we can easily find the value of x for any new value of a value of y for any new value of x using this function, and that would be called as prediction. That would be called as prediction. Now, before going to next slide, let me clarify. For example, if I have been given an equation y is equal to x, suppose this is the equation given to me, I draw a curve and I know that this would be the curve, because if I take value of x equal to 1, means I am taking dependent variable as 1, the value of independent variable would also be 1. If I take x equal to 2, the value of y would also be 2. So we will plot all the points. I hope we all know this, and we will draw this curve, draw this line, and we can say that if I want to find out what would be the value of y if x is given to me. X is given to me is 6, and I want to find out the value of y. Because I know about this curve, I know that this is the function that is actually found according to these coordinates. I have found that this is the function. So it would be easy for me to calculate the value of y for x equal to 6. Do you agree on this point? So when I said x equal to 1, the point was 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5. These were points given to me, means these were the features and labels given to me. What I did, I had this graph. From this graph, I found the function. What is the function? I hope we know that whenever we have linear equation, the function is kind of this. We can find out the equation for this line as y equal to mx plus c. We calculate the value of m. We calculate the value of y-intercept, that is c. And then we found that y is equal to x. This is the function. So once we have this function, once we have features and labels, now for a new value of x, we can find out the value of y. So we did, once we found this function, this is called as training part. Once we have the training, then next thing we do is called as prediction part. I would brief once again what I want. I have been given input, what I have been given output. From this input and output, I am going to find out a function. After this function, I would find the value of y for a new value of x. For a new value of x that would be given to me. Here in this case, we took the example of 6, right? Input, output, finding out function. This particular part would be called as training, and the next part would be called as prediction. So till now, what we know that there is something called data set, number one thing. We know there is something called dependent variable, that is called as label. There is something called independent variable, that is called as feature. After that, we know that there is something that we call training of the model, and there is something that we will predict. So these are basic things that we must understand. Whatever model we are learning, whatever things in machine learning we are doing, I always require, first of all, data set. I always require label. I always require feature. Then I train the model. Then I predict the value. This is actually what is our objective. Any doubt in this case? Is there any provision of hand raise or something? No? Any doubts? Can we move forward? Okay. So let us move to the next slide. We have two types of supervised learnings. One is called as regression and second is called as classification. Now, when I say it is a regression, regression means my output would be a continuous value. Continuous value means numbers. Some values, some number would be assigned to the output. For example, I want to predict the score of match. Second thing is, when the output is discrete value means there are some categories or there are some classes for the output, then that would be called as classification. So we have numbers, we have categories or classes. For example, whether the match would be win or lose, right? Whether today there would be rainfall or not. So answer is either yes or no. But here it would be exact number. Let us find out of these things, what is regression and what is classification. If I want to predict the height of a person, I have been given like data set where it says age of people is this and the height is this, age is this, height is this. Maybe there is one more feature which says that what is the gender for male, female, male, female. Now I want to find out, there is a person who is male with the age 25 years. What should be the average height? I want to predict that. So what is this problem? Is this regression or classification? Uh, we can understand this is a regression because it is asking for a number, right? If I want to predict weight, again there is a number, so it would be regression. When I want to predict whether it would be a hit or a flop, then this would be called as classification problem because there would be two categories only. If I want to predict the score, regression. If I want to predict pass fail, it would be classification. Prediction of salary would be regression, right? Now consider so supervised machine learning models. What we would be learning is there would be different models that I have few in my mind that we would be doing today, but there are many more models for supervised machine learning, right? So consider this particular data set. Now this data set says there is there are students, and one student who worked, whose efforts are 2.5 hours, that student scored 21 in the subject, right? Second student who put the efforts 5.1, score was 47. 3.2 score was 27. 8.5 score was 75. So on the basis of these features and labels, I want to find out what would be the score of a student if he has learned for 10 hours. He has put the effort of 10 hours. So this hours is given to us and we want to find out the score of that student. How to find out the score of the student? कैसे find out करेंगे? To find out this, we are required to first of all find whether it is the case of supervised machine learning or unsupervised machine learning. Second thing, if it is supervised, then whether it is the case of classification or regression. Once I get it, if it is the case of classification or regression, then I'll move forward for my pre-processing of data types. Pre-processing of data means I want data sets that is to be given. I want features to be identified. I want labels to be identified. Then there would be finding out the function, and then there would be prediction. So keep in mind these 5 basic steps. The number one step would be loading of data. Number 2 step would be segregating features and labels, and then finding out the function, and then after that prediction. So all these things are required to be done in case of this thing, any kind of developing any kind of model, right? Now we have, in this particular case, we know that hours are given to us, means I can say that this is the feature and independent variable. Now, second thing I am required to find out score. Score find out, this means label or this is dependent variable because it is dependent on number of hours the student has put the effort, right? So now I have identified what is the feature and what is the label. This was my first step, right? So in this particular example where we have taken hours and score, the same data set is here. And my aim is to find the score if a student studies for 10 hours. We are given hours as feature and scores as labels. Now both features and labels are given. So this becomes, we know that this is supervised machine learning. And because we have to predict a value or a number, I said if regression is there, then you are required to find out continuous values. When classification is there, this means discrete values. Continuous values means we are required to find out value or number. So we are required value or number to be predicted. Therefore, we would apply regression from supervised machine learning. Any doubt in this case? Sonia ma'am, can we interact with, can I interact with the students somehow? I don't know. Acha, there are faculty members only or research scholars, right? So can I interact with all eminent faculty members?
Ma'am, hello.
Sonia ma'am, I just wanted to ask, can I interact with faculty members by somehow, maybe simple, they have the access of raising the hand?
Yes, ma'am, they have the access of raising the hand.
Okay.
Sorry.
So if we, thank you so much. If we are clear till now, please raise your hands. Can I see the hands only so that I know that I'm going on the right path and I am audible also properly? May I request faculty members to please raise your hands in case you are with me? Thank you so much.
Ma'am,
Yes.
uh, can I provide the mic to the participants? I'll give the permission of
Okay.
just if you want, I can just provide the access to the mic.
Okay. As of now, this raising hand will work. In
Okay.
case they have any doubt, you can provide the mic, right?
Yes. In case any of the participant has any doubt, you can just raise your hand. I'll just give you the permission of the mic at that moment. Okay.
Right. So next we have, now we know that we would be moving towards regression. Now, what is the concept behind regression? We know, as we discussed initially also, suppose there is a value for x and the value is a list 1, 2, 3, 4, 5. For y, we have 1, 2, 3, 4, 5. And we know that there would be a line for this particular equation because we know that equation for a line is this. And if we want to find out the value of m, if we want to find out the value of c, we know how to find out. I hope we all are aware about it, how to find out the value of m and how to find out the value of c. M is always delta y by delta x because this is the slope and this is the y-intercept, right? So once we are done with this, we know that the value, the equation would be y is equal to x, right? Now, suppose we are given, now we are moving to the main concept. We are given the values for x as 1, 2, 3, 4, 5 and y as 4, 5, 7, 4, 5, 2, 3, 7. We know straight line is not possible. So all the points we have drawn here, right? But linear regression, keep in mind, it always works on a straight line. It draws a straight line. Now what it will do, it will try to draw a straight line which goes from the maximum number of points, right? It can be any straight line, right? Because we want the data to be predicted in such a manner that we are given this x, we are given this y, we would find the function and the function would be found through linear regression, and linear regression works on straight line principle, right? Now here it is not possible. So what it would do, it will find out best line, best fit line. Now this is something that has to be done by linear regression model. Best fit line has to be drawn. Now, best fit line, how to find out what would be the best fit line out of these lines? This is the concept for it. For every line, for every case, it will find out the distance of actual point from the distance of actual point from the line that it has drawn, and it has said that it would be closer to most of the points, right? So one line is drawn, it called it as best fit, right? But there are many other possibilities also to have other lines, right? So what it will do, it will find out the distance of all the points, from this line that it assumed as best fit line, right? Suppose this is the distance D1, this is the distance D2, here it is D3, here it is D4, here it is D5, here it is D6, right? So now second thing, what it will do, how to find out this distance? This is very easy, right? Why this is easy? Because we know that coordinate of this particular point, maybe it is 5 and 21, and coordinate of this point is 5 and 28. We can see here, and to find out the value of D1, we know that we are just required, because this is 5, 28, this is 5, 21. So what is the distance between this? This is 7, right? And this particular distance is called as residual. This is called as residual. Now, what is residual? Residual is the distance, how far a particular point is from best fit line, right? Now, after finding this residue, now you can assume, you must understand that residue can be residual or residue. It can be negative also, because from this particular point, this distance would be negative, and it can be positive also. And the final value means D1 can be negative or positive. D2 can also be negative or positive, right? It can be negative or positive. So what we want, we would take square to avoid this negative kind of things. We would take the square of every square of distance of every point, right? And after that, we will find out the summation of all the squares of all distances and divide it by 5. The line which has minimum of this thing, that would be called as best fit line. Now what we have done, I'm repeating. First of all, to find out best fit line, why best fit line is required, we have seen that in this particular case, we are not able to find out a line that passes through all the points. So I require a best fit line, right? Now, best fit line would be that is very close to all the points. To make it very close to all the points, I have to find out how far this line is from every point. I found this thing is called as residual, right? Now, I found that residual can be negative also, positive also. So what I did to remove that negative kind of thing, what I'm doing, I am just taking the squares of all things. All points are to be considered. So we have taken the square of distance of all the points and then taken the average of this. And this is called as another term, that is mean square error. This is called as mean square error. And the process of finding out this best fit line, this optimization technique in which I'm optimizing the this line, and the distance of the points from this best fit line is minimum. I want to optimize this thing, and that process is called as gradient descent. That is called as gradient descent. So again, we have done two more things in this linear regression. After that data set, label, feature, now we have moved to the another point, that is regression and classification. Out of regression, we started with linear regression. In linear regression, we saw that there are two more terms, that is, one is best fit line. To get this best fit line, we require MSC, and to find out MSC and best fit line, the process that we called is as gradient descent, right? So what is best fit line? Best line that gives minimum mean of square of residue. This is also called as MSC, or mean squared error. How to find out that? D1 square, D2 square, D3, D4, all distances, we have taken the square. And once we have a straight line, now it is easy for us to find out M and C. M and C, find out, if we have found M and C, this means easy for us to find out F. What is F? Y was F of X, means it is easy for us to calculate F, and then we can find out the new value of Y for a new value of X. So whole story is this: we wanted to train the model. To train the model, we wanted to have a function. To have a function, we wanted to have a linear equation. To have that linear equation, we require best fit line. Once we got best fit line, we got this linear equation, we got this function, we could train our model. And finally, after training, prediction becomes easy because we are given the value of x, f we have found. So this is the whole story behind the linear regression, right? Now, how to implement? We are moving to the Python. I hope we all have our systems with us and we can go for Python programming now, right? So the very first step for implementation would be import of libraries. Then we would be requiring loading of the data set, right? I said we require loading the data set. Once we get the data set, we require segregation of features and labels, means dependent and independent variables. After that, we fit linear regression to the data set, means this is called training. What we said, we want to find out a function. This means here we want to train the model. Fitting means training of the model. And once we train the model, we can predict the results from that model. And then we can visualize it. Visualization can be done graphically on console, anyway, right? Is this clear? So should we do step by step how to move ahead, right? Now we would be implementing this linear regression in Python. Important libraries for this, I hope you know about matplotlib. This is required if we want to visualize the results in Python. It will give us a graph, it will give us a pie chart, whatever we require, we can obtain from this with few commands only, right? NumPy is very important library because it will give us, uh, it will help us in mathematical operations. I hope you have done list in Python. List in Python, if you want to add two lists, there are 5 numbers, 1, 2, 3, 4, 5. And second list is, this is list 1, list 2 is 6, 7, 8, 9, 10. And I want to add these two lists. I want to add the numbers from these lists. I can do it through list operations. But if there are lakhs of numbers, then definitely I would require some efficient operations. And that is done with the help of arrays, and that is NumPy word for us, right? So NumPy will help us to do all data operations, all mathematical operations that we want to perform on data, right? Next is Pandas library. This is actually the lifeline of data analyst or a scientist. Machine learning without pandas is not possible for us. Otherwise, we would be working and working and working without any output, right? And the last library is sklearn, that is scikit-learn, basically for machine learning only, right? Here you have all models. You already have models. What you require means, if I talk about linear regression, that is already there. If I talk about logistic regression, that is already there. If I talk about SVM, that is also there. So all models are already there in this. In Python, we would be using these models as per our requirement. So the basic thing is, we are required to upload the data. Data uploading would be done with the help of pandas. We want to segregate our features and labels. Again, pandas. We want features and labels. Ke baad we want that model has to be there. Then we would be requiring scikit-learn. After that particular thing, we would be giving some input. What is to be, what would be the value that we want prediction, that input would be given, that would be called prediction. Again, for that we would require pandas and scikit-learn, and finally we would be able to see the output, right? NumPy would be required. Some people say NumPy, some say NumPy. So okay, for me both the things are okay. So NumPy and NumPy, this library would be required for some mismatching, for matching some of the things where data is required in a particular format. So we would be using NumPy, right? So this is all about important libraries, and now we are moving to how to go ahead in Python, right? Now let me take my compiler with me. I'm just opening Anaconda. and you may work with me. We would be working on Spider. Okay. So, Sonia ma'am, please share this data with all of them.
Okay, ma'am. Sure.
Till the time this file reaches to you, the first step we talked about was importing of libraries. As I said, we would be having how many libraries? We would be requiring 4 libraries. But here I have taken only 3 libraries because scikit-learn I would be talking whenever required, when it is required, right? So the first library, when we are importing it, this is the syntax for it: import pandas as PD, right? This is alias for pandas. So next time, whatever we want from pandas, we would be using it with the help of this PD. Next is we want to import numpy. Alias for that is np. Third thing, we would be wanting matplotlib.pyplot as plt, right? After importing these libraries, I'll be giving you commands. We would be writing it on Spider, just understand. Then second step, we always talk about loading of data set. To load the data set, we would import the file that I have shared with you, that is student scores, right? So we are going to import that file. Dataset equal to pd.read underscore CSV, because it always take data in the format of CSV files, comma separated values, right? So because PD is actually implementing pandas, so we have written data is loaded into this data set. Now, because we have the data set, let us see this data set, how it is plotted, whether this is the case of linear regression or not. If we see that, the plot of that, this will plot my data set. You can see, yes, it is something called linearly separable, means we can have a line that will give me the best fit line for this model. And once I get that best fit line, it would be easy for me. So I can go for linear regression, right? If I have plotted this line, then we can move to the next step. Data set is uploaded, right? After that, next step was finding out features and labels. What is feature? We know that feature is data set के अंदर I am taking just one field. Data set was consisting of 2 fields. One was hours and second was scores. So I am taking first field as the feature and the second field would be as the label. Now the very first field, if I want to have features, I can write this way also. Features is equal to, I want from data set only one column, and that is hours, right? I can write in this manner also. But what will happen when I am writing in this manner, then it will give me index also, and it will give me the value of hours also. But I don't want this index kind of thing. So we have just taken dot values, means it will give me only features part, right? Second thing would be label. So first we have data set, second we had features, third we have labels. Labels are scores from data set. We got the values, and then we have this command print labels to just find out whether these labels are actually having some data or not. So this print label, print feature, this is not important command. This we have just to see whether the data is uploaded, whether features have the this independent variable and labels have the dependent variable or not, right? Next step is fitting of the model. So let us do first thing, that is segregation of features and labels. Till this point, let us complete our thing and then we will go to the scikit library, right? Now this is Spider. I hope now you all have the file with you. This file has to be in the same directory where you have Python programs, right? So this is the CSV file that I am opening now, right? Are you all with me? Do you have this CSV file with you? Okay. So I hope we have the CSV file where we have all, where we have complete data. So we have around 20 participants. 20. Can I see at least 10, 12 hands so that we can move forward? You have the file with you and you have opened the Spider. Okay. So let us open a Python file. Let us create a new file. And here we can start importing the libraries, right? The very first thing we wanted to do is importing of pandas, right? Second thing we did was import of numpy, and third was import of matplotlib. Is this clear? Right? The second thing we were doing was loading of the data set. And let us see if this particular part is done or not. So till this point, what I have done, should I increase the font size? What I have done, I've imported 3 libraries,
Ma'am,
pandas,
it's visible. It's visible.
and after that, in the second step, what we did after importing of libraries, the second step was uploading this CSV file. Now this CSV file, I'm again saying it should be in the same directory. In case you are not able to do it, please follow these steps because it will not allow you to run the program in case this is not in the same directory. You can go to file, you can go to open, and wherever your file is, you just copy here, right? And that file would be in your directory. If you are not able to locate your directory, you can just copy that file and paste it here, right? And then you can open it. Now let us see what we have done till this time. Right. It says something, let us check. It says that figures are in plots pane. Right. I wanted, data set is there. I wanted to see this plot. What are my data points? What is the data that is actually, in case of graph, if I want to see what is that data, right? So how to go about it? Go to this tools, go to this view, sorry, not tools, go to view. In view, you have panes. In panes, you have plot, right? View, panes. In panes, you have plots. Now, I can see here, just above the console, there is variable. This is console. This is all console. Just above it, I can see these points. One is called Variable Explorer. That has data set. Let us click on that. You can see the file has been uploaded and there are total 25 rows. Because indexing started from 0 and the final row is 24. So we can say that there are total 25 rows, right? That is Variable Explorer. After that, I go to plots. If I have done it through view, then there would be another tab called plot. In this plot, the same curve that was in my PPT slide, you can see that curve over here. So this is my data set. Now this has been uploaded properly, right? So data set is with me. Now what I want next, I want segregating features and labels. How to segregate features? This is the command. How to segregate it? This is the command. Features equal to data set. Out of data set, I want hours only. And then values of that, because I don't want index. Data set may we have seen the index from 0 to 24. So I don't want that. Right? Hours and values of that. We have printed it also. Let us see. Now we must have features with us. Can you see on the console? You have all the features values with you. Right? If I go to Variable Explorer, now you have two variables. One is data set that we saw, and the second one is features that is there, but there is no column for index, right? Okay. So next I want, after getting features, I want labels. So how to get the labels? This was my next step. And how to get it? In the similar manner, that is labels. Again, let us save this file, execute it, and you can see on console, you have labels, means the scores. Now, Variable Explorer, if observed, it gives me one more variable, and that is label. Right? Once we are done with this, features and labels, Then we can move to the training of the model. Just let me know, give me a signal when you all are done till now. I'm just waiting for the reply. Once you all have done it, you can just tell me. Maybe one can just share it and then I can move forward.
I hope done, ma'am.
Right. So now we can move to the next part, that is fitting of model. Now, fitting of model says, as I said, very, very important library is scikit-learn, right? In this, you can see, just a minute, I'm finding my pen tab. Yes. Okay. So fitting of model means we want this linear regression model to be used. I said scikit-learn. This is the library which has all models, right? So it is easy for us to use this library and have our model and prediction. So the story is left for just 2-3 lines more, and this says that from sklearn.linear model, right? Now we are importing the model that is named linear regression, right? So after this importing of model, we are required, see, this is kind of class, right? Class will work when I have an object, right? So I'm creating an object of this model in the next step, right? So what we did, we started with sklearn.linear model. That is basically the library where all the models are there. So out of this library, which is scikit library, and the short form is sklearn that we are using, we have imported linear regression class. Linear regression class would be used with the help of a model, with the help of an object that would be called as model over here, and that is a regressor. So we have named it as regressor. This is the line for getting this model. Now, once I have this model, I'm required to get the best fit line, and I am required to train that model. If I want to train that model, what things I would be requiring? What things I would be requiring? Definitely, to get it trained, I require my features, I require my labels. Means I require the value of X, I require the value of Y, and then I would like to find function out of X and Y. This is machine learning only. Since beginning, we are talking about this, right? So same thing would be done here. This features and labels, this would be passed to this regressor object or model, and we will use a function fit. Now, what this fit function would do, this will find out that best fit line, right? That best fit line from these features and labels. So features and labels, we are giving it as input. Using features and labels, it will find out best fit line and the model would be trained. So training part is basically this line. This is the story for training part, right? So if I want to train my model, means I fit this is called fitting of model. That would be done with the help of this line, that is regressor dot fit, right? Nothing else. Regressor dot fit would require features and labels, right? For the time being, I'm skipping this line, features equal to features dot reshape 25,1. I'll clarify that in the next few minutes, right? Once we have fitted it, now what is next left for us? Prediction. Machine learning means prediction. So we want prediction. Prediction के लिए we are using this thing only. What is prediction? Again, the name of the constructor dot predict. Predict is again a method, again a function. With this constructor from that class of linear regression, we are using it for 10, right? Why 10? Because my objective or aim was to find out the value of y if the effort put by student is equal to 10 hours, right? What would be the score if the efforts are for 10 hours, right? So 10 hours efforts are there. Y ki value we have to find out. To find out the y value of y, we did fitting of the model, means training of the model from the given data. And then we want to predict the value. For prediction, I'm using regressor.predict. In braces, it is 10. What is 10? 10 is the input, new input for which I want to predict the data, right? Now, this is basic step. And before that, these are few things we are required to do. What we are required to do, see, linear regression mein features are always required in 2 dimension, right? And 2 dimension, to convert it into 2 dimension, my pandas library say that, or numpy says that, what I can do, I can convert single dimension features. Remember, features are like this, right? This is single dimension. If I want to find out its dimension, features dot dimension, it will give me 1. When I want to find out what is its shape, features dot shape, it will give me, there are 25 values, 25 comma this, because there is no column. It is 1 dimension data. I want to convert. If it is not converted into 2 dimension, it will give me error, right? So I want to reshape it in 2 columns, right? In 1 row and 1 column, right? 1 row or 25 rows, right? But I want column also. So what I am required to do, I'm going to reshape it. And how to reshape it? I know total number of rows are 25, and 1 more column, I want it in the format of like this, right? First value, second value, third value, fourth value, fifth, sixth, and so on, right? So for this purpose, we are using this line. My model is complete. My linear regression is complete with this line when I called it, with this line when I imported the library, with this line, and then the prediction line. But it requires my Python syntax, my machine learning requires that I must reshape my data, right? So this line was important. To reshape again, when I want prediction function for X. Now what is X? X is a feature. Again, it would say we require it in 2 dimension, right? First of all, X is integer value. Definitely, it does not require it in integer. It does not require integer value. It requires, we will convert this integer to list. After conversion of this integer to list, I would take it to NP word, right? Now, NP word, once it is in NP word, then I would reshape it into this one, right? So these 4 lines are required to eliminate those syntax errors, right? It says whatever value you want to predict, first of all, put it in X. So this becomes feature. I want to predict a value for this feature. Second thing, make it a list. Third thing, convert it into NP array and then reshape it, right? Now it is good to go. Now I can have my results. The results are, these 2 lines are basically for, I wanted to print the feature, I wanted to print the shape and all those things. But this is the prediction part, 100.24170,731, right? So this is the prediction part. Let us do one by one all the steps that we have learned so far. Segregation of features and labels was done. Now we are left with fitting of the model. This means training of the model, and we can type the commands so that we can fit the model. The first thing we did is importing of library because we want the algorithm to be imported. Second, we created the object of the class. Then we reshaped it. After that, we want fit function to train it. And then I want predict function to get the output. Is this done? Should I wait for 2 more minutes?
Done, ma'am.
Done. So now let us save it and see what does it say. Right? Finally, we have list of features. In console, we can see labels, and this is the predicted value. Right? If I want to check variable explorer, data set I have, features I have, then the labels, and after that, this is the linear model, and then the value of X. Right? Now, next thing I want, let us see whether it performed that best fit line method or not, right? I want to visualize it. And to visualize the results, this line has been plotted, and with the help of that matplotlib, that we have taken an alias for that as PLT. So let us have that PLT plot and visualize the results. You can see here, I want a scatter, I want a plot with all these predicted values, title of this, label of this, label of x-axis, y-axis, and then show me this plot. These are simple commands which we generally study in data visualization, and I guess you would be studying in details. Some optional features like color equal to red, color equal to blue, that is there. Let us run it and see the plots. You can find the plots over here in the plot pane. Right? I hope this result is with all of you on your systems as well, not just on my screen. Now with this basic concept is done, because this would be required everywhere in every model. So I had this flow. Just let me know if this is done. You could understand it. Now I would require your hands to be raised. Please raise your hands if you could understand how to implement it. Yes, Bhavna ma'am, I can see your hand always. What about others? Yep. Thank you. You're free to share in case you want some other way of covering this. Okay. Right. Thank you so much. So let us move forward. Back to my PPT slides. Now, next concept is, after this visualization, the next concept is train, test, split. We are talking about machine learning. We want to train the machine. Now, to train the machine, how to train it? Out of the given data set, I must have something that is called training set also. And after giving that training to the model, I must test also, right? Whether this model is good to go for predicting the values of outside world or the people who are using this model. Before giving it to, before deployment, it should be tested by me also. What is the score of this model? What is the performance of this model? And to get it, I must have two things That first thing is I'll split my data into two parts. First would be called as training data, and the second would be called as test data, right? For features and labels, for both of the things, you will have both features train, features test. Means training data for features, testing data for feature. Similarly, training data for labels and test data for labels, right? Now I want to split my data set into features and labels, and features would also have two things. One would be training data and second would be test data. Same with labels, train data and test data. For implementing this particular thing, what I require, I want to change few things. Number one thing would be, again, from sklearn library, I would import train test split function. Train test split function. Now, what does it do? This train test split function, it will split my features and labels. This is the input, this is the input. So it will split my features and labels with a particular data size. What is the size? If I say the test size is 0.2, it means that 20% of data would be test data. Remaining 80% would be data for training purpose, right? So I can have 70-30 also, I can have 65-35 also. Whatever value we want, we can have, right? But here we have taken 80% of data as training data and test size is 0.2, means 20%, right? Now, train test split function has taken input as features and labels and the test size, right? Now, what it is doing, it is splitting the data feature into features train and features test. Because it has 0.2 or 20% size for testing, so 20% data would be saved here and 80% data would be saved here. Similarly, we will have labels train and labels test. So train test split, what it did, it splitted the data, features train, features test, labels train, label test. Four values we would be getting, four variables we would be getting. The first variable say 80% of data, second variable 20%, then 80% of corresponding features train and 20% of corresponding features test, right? So this is the splitting of training and testing data. Now, how to train it? Again, training of the model, we know that the same steps are to be covered. What are those steps? From sklearn linear model, import linear regression. This is the class, this is the constructor. We have linear regression, constructor has been created. Then we have regressor.fit. Now, if I have regressor.fit, I must give the data because I am training. Fit says training of data. Now, please observe training of model. So please observe this change. It says that you are required to take the input as features train and labels train. Training data is required for training of this, right? In the previous part, we have taken from this model, we took it features and labels. But now I would be requiring features.train and labels train, right? Once I get it, the next step would be prediction. For prediction, you have regressor.predict, same function, but the data for this would be features underscore test, right? Because you want to predict the value of testing data. So once you have observed these changes, you would be able to see the values of what we wanted to print. This is predict data, the score for 10. And last is what is the score of model. What is score of model means what is the performance of model. Now what is the performance of model? Model accuracy kya hai? To get that accuracy, we would use the function score from the regressor and we would get features test and label test, how accurate it is, how much percentage accurate, or what is the value of this score. Feature strain and label strain, and then what is the value for this score. So this score will let me know how good my model is, right? So along with what we did in the previous part, now we would be incorporating train test split and the scoring of the model also, right? We would be taking train test split and the score of the model also, right? So let us go back to the point where we left, and this is the file for the same thing. We had import, then we had data set, then we had plotting, features and label segregation is done, the same steps. After that, we had this thing. From scikit-learn, we imported linear regression. Then we had regressor class. Till this point, it's all same. Now, next point is this, right? From this point, this reshape is also done. From this point to this point. Is this visible here?
Yes, ma'am. It's visible. I hope all done, ma'am.
Okay. So results are done and we could understand the results also, right? You can see on the console, we have shape that we printed for just checking. This is the value that we wanted to predict, right? We wanted to predict it for 10 hours, that is there. And after that, this is the score of the model in the end, right? So this model will give me such accuracy. Okay, so it's good to go for this model, for this particular data set, right? Now with this linear regression part, I guess we are done with the linear regression part, and you can just see the slide sorter view and take a minute to see in case you have any problem, right? We started with what is AI and ML, then traditional programming and machine learning. We know what is data set, features and labels. What is supervised machine learning? Then regression and classification. We should know the difference between regression and classification, because when we want a number, then it is regression, and when we want a class, then it is classification, right? So identification of these problems, and then after that, whenever a straight line is possible, then we can go for linear regression model, right? Linear regression, we started with the concept. We had a data x equal to 1, 2, 3, 4, 5, y equal to 1, 2, 3, 4, 5. We drew the line, and we knew that it is easy for us to find out the value of y for any value of x, because we could find out the function. But if there is not such case, then the concept was slide number 17. It said we are required to find out best fit line. To find out best fit line, we are required, in the slide number 19, we could see that we are required to find out residue, right? To find out residue, we knew that residue is the distance between the point and the best fit line. We found that and observed that it can be negative also. So for just eliminating that negative wala part, what we have done, we have taken the squares of all the residues, and then taking the square of all the residues, finding out their summation and dividing by 5, because we had 5 number of values. So that basically we wanted to take average. So that would be called as mean squared error. And to find out this best fit line is called as gradient descent. Implementation, then we move to implementation part. Implementation said that basic steps are importing of libraries, and then we require to upload the data set. Once data set is there, we are required to segregate features and labels. And then next step is we require fitting of the model, then predicting, and then visualizing. So libraries, 4 libraries we are taking help of. We imported all the libraries with their alias names. Then we loaded the data set. Data set has to be in CSV format. Then we started with this segregation of features and labels. Features and labels, they had the dimension 1, but linear regression required 2-dimension data. So we reshaped it while fitting the model. When we were fitting it, we had to import the class from sklearn. sklearn से import करने के बाद what we had our fitting regressor.fit function. For predicting, we had regressor.predict function, and then we visualized. After that, we learned 2 more things. One is train test split. Train test split we had done. We have implemented this also. And then we found the score of the model, right? Now we are good to go for next part and the next concept. Though we have classification, what we should study next. But before that, I'll give you one more concept, and very important concept, that is for multiple linear regression. Now, what is multiple linear regression? See, in my data set, I have seen that I have been given 2 things. One is hours and second is score. But what will happen if I have been given the features which is not just one? I have 2, 3, 4, 5, many features with me, right? Label is just one, means I want to calculate value of one thing only, but based on many features. And that thing is called as multiple linear regression, right? Implementation is not more important. Reason, the same manner we would be doing it. Only thing that would be changed is when I am extracting the features, remember what we did? We have written a command, dataset dot, what was that? We wanted hours from dataset and dot values. It was dataset. Out of dataset, we wanted hours. And after that, we have written dot values. But in this particular case, because I have n number of features, there are many features, I would be replacing this command with another command. And that command is, please make a note of it. That command is dataset dot ilock. This is command from pandas in NP. After that, this will give me number of rows and this will give me number of columns, right? This is actually for finding out a particular, to find out particular number of cells in a data set. What we want? We want from data set few cells only, right? What are those few cells? Yahan pe we are required to mention the rows and here we are required to mention the number of columns. Now in the rows, I want all rows, right? I want all rows. Of course, we want to analyze complete rows. So I will not put anything here. I'll not put anything here. This would be blank. In the set of columns, I can write whatever specific column I want or whatever columns I am, means numbers of those columns, right? What would be the number of columns? Suppose I have total 4 features. Total features, number of features are 4, right? So indexing always starts with 0, 1, 2, and 3, right? So I must have features, means I must have columns, column number 0, column number 1, column number 2, column number 3. So how I would specify it over here? I would start from column number 0. I want to go for till column number 3, but I have seen, we have seen in list also, right? The last number is always excluded. So what I would write? I would write 4, right? I'm repeating what I did. I said if there are more than 1 features, right? If it is like this, then I am required for multiple linear, I'm required to do multiple linear regression. Nothing important in implementation, because implementation sklearn library gives me in the similar manner whatever we did in linear regression. The same model we would be calling for multiple regression, right? Nothing else. But what other changes we require is in this features. Now, what is features? I said more than 1 features are there. So how to segregate features and labels? So features would be having from my data set, I must have particular number of locations. For that, I have written ilock. What are those particular number of locations? I'm required to put here. The first parameter says rows and second parameter tells me about what columns, which columns, right? For rows, there would be starting row number, there would be ending row number. For columns also, there would be starting column number and ending column number. Now, what is starting column number? What is starting column number for this? Just a minute. Okay. What is starting column number for this? It will start from 0. What is ending column number for this? 3. But we know that it will stop before this last. If I want to stop it at 3, I should write 4 because last one is excluded. Because I wanted all rows as the part of features, so I'll not put anything in this location, right? So this is my final command for finding out features in multiple linear regression, right? Similarly, let's go for labels also. How to identify labels? To identify labels also, I would have same command, dataset.ilog. In case there is only one label, definitely we can specify from with our previous method. But here, if I have multiple number of labels, then I would specify like this: all rows, and the last column is always indexed by -1, keep in mind. So the last column, for the last column, I can write -1, right? So this is how I'm going to find out what are the features and what are the labels, right? Now, one more thing, after getting this multiple linear regression concept, another concept is, if I have a data set where I would be having data as, for example, department is there, salary is there, experience is there, and increment, right? See, this is the data set which says that there is some person who is from development environment, there is some person who is from UI UX department, there is some person who is from web development, and the salary of this person is something like 2L, 3L, 2L, 1.5L, 3L, because experience was 4 years, 5 years, maybe 3 years, something like this. And same, on the basis of their experience, we want to increase their salaries, right? Now, in this data set, what is particular about it, right? Definitely, on the basis of department salary and experience, I can find out what would be the increment. So features for this data set would be this. All these features. What would be label? Label would be this, right? Now features, because it has 3 features, so definitely my previous command that I want to segregate features, it should have column numbers from 0 to 3, right? Label would be from -1, right? I hope this is clear. Now, what next very particular about it? It is this field, department. Because it is categorical department, keep in mind others are numbers, all other things. In fact, the previous example was also considering only numbers, right? But in this case, we have data set where we have categorical data in one column, right? Now this categorical data, how it has to be considered in linear regression, right? To consider it, I am required to change this categorical field into numeric field. This categorical field has to be converted to numeric field, right? How to convert it? I'm giving you the concept of that, and that is called as one-hot encoding. That process is called as one-hot encoding, right? This one-hot encoder, what it is going to do, it will convert my categorical data to numeric field. Now, how will it do that? Let us see. How would it do it? Right? We have seen in the department, if you observe, there were 3 categories. The first category was development. Second category was UI UX. And third category was web development, right? This was maybe software development, UI UX, and web development. Now, what it will do, one-hot encoding process, it will have 3 columns for it. Software development, UI UX, and web development. It will have 3 columns. It will see जो मेरी first row है, row number 1, if it belongs to development, so category of development would be replaced by 3 values. It will say 100. So my one column of department, number 1 thing, one column that was of department, that is converted to S development, UI UX, WD means 3 columns. Number 1 thing, first point to be noted, right? Second thing is, depending upon the data, In row 1, if the department is development, I would put software development 1 and other values 0. Means other columns would be filled as 0. If second was UI UX department, then this would be 0, this would be 1, this would be 0. Third row was from web development, then this would be the data. Fourth row was again from software development, this would be the data. Fifth row again from UX, this would be the data. And the last is maybe this is the data, right? So what we did, we converted categorical data into numeric data, and that is done with the help of what? With the help of one hot encoding process. I hope this process is clear to you,
Yes, ma'am.
right?
Yes.
So now, thank you. So one hot encoding process. Now, if you see in this one hot encoding, you can observe that if I know the value of two fields, I can definitely find out the value of third, right? Because it is categorical data. If there is one, then definitely one won't be there in any other column. If it is one, definitely one won't be there in any other column. If both are 0, means definitely there would be one in the last column. If one is there, no one for the next field, right? So this is called as redundancy of data. What we call it as redundancy of data. Now I want this redundancy to be removed, right? So one hot encoding, this says that we can filter the desired data, right? We can filter the desired data means now we would be having just one thing, that one column is converted into two columns, right? Not three columns. We have removed this redundant data, and now one column would be actually omitted and converted into two columns, not three columns, right? So it has filtered the data also, right? Now from where this whole thing would be done, if I want to implement this thing, that is simple. Implementation is not a big deal. Reason, because we have for this also, we have a class, we can have our constructor, we can have the processes, because there is a process called column transformer, very important process. What it does, it takes some input, like encode karna hai, kaisa encoding karna hai, because that is one hot encoding. Then it requires which column you require to be encoded, that is column number 0, because that department was column number 0. And then it requires what has to be done for other columns, means remainder, you say just pass through, nothing else to be done for any other column, right? Once you have done this column transformer, then you use a process called fit transformer. Now what is to be fitted? Features to be fitted, right? So this will fit the data into this. Clear? So all other things remaining same, the only thing that is to be done is this one hot encoder process. I hope this part is clear. So now what we have done till now, we started with simple linear regression, that is clear to us. All importing libraries se leke till predicting the result. Second concept, we did train test split, that is clear to us. After that, third thing we did, after completion of linear regression, we started with multiple linear regression. In multiple linear regression, we had all steps same, except one thing, that we are required to find out features, we are required to find out labels, and then we are required to do that one hot encoding if there is some categorical data, categorical feature. Yes, any doubt till now? Rest things will remain same. We would split the training data, split the all those things will remain same. Clear? Can we move forward? We have 15 more minutes.
Yes, ma'am.
So this particular algorithm, maybe I can give it to you and you can try on your own, and I'll give the data for this also, right? Now we are moving to the next concept. Let's see. It says that this is the data set And here data set includes total number of features as 9. V1, V2, V3, V4, 5, 6 means these are the vitals of some patients. This is a health care data where it is finding out whether a person is hurt patient or not. To find out that, we have all the vitals of the patient. There are total 9 vitals which has been taken, and depending upon these vitals, we want to predict whether the person is heart patient or not, right? For this particular thing, what we can say, what are the features? Features are from column number 1 to column number 9. What is label? Label is last, and that is class. Now, whether it is a regression problem or classification problem, first of all, we are required to find out that. Right? Definitely, it is a classification problem. Reason? Because it has just two answers, whether the person is hurt patient or he is not. Right? So, discrete data, classes, categories, classification. Right? So, we have this problem, this data set for our next problem, and that is based on classification. Right? Classification where we have discrete values, and today we are going to learn 3 algorithms for classification. These 3 we would definitely do, rest let's see. Now what are the steps? The very first is logistic regression. Again, steps would remain same definitely. First step is called data pre-processing, right? Now whatever we were doing, what we were doing, we had that uploading of data, right? Features extraction, label extraction. First was uploading, second was features and label extraction. Third was, what was the third thing? Third was train test split. Fourth was in case we require one hot encoding. All these things are called as data pre-processing because all these things are to be done before fitting of the model. So this would be called as data pre-processing, right? Data pre-processing step, once it is done, then we will go for fitting of that model. Fitting model, we know that very, very easy because sklearn library gives me everything. Predicting the result, again, very, very easy. sklearn say we will have that predict method and we will do it, right? Then comes what would be the score or performance. Here to calculate the score and performance, we use one more thing, one more concept is going to be there, and that is called as confusion matrix. And finally, we will visualize the test results, right? So confusion matrix is something that we are required to learn in this classification. Rest of the things would be almost same, right? So can we start with this data set? First thing, pre-processing. Pre-processing, very first part would be, we will upload the data set, we will find out labels, we will find out features. Now, because you can see the data set had 9 features. So how to get the features, right? All rows, features from 0 to 9, and definitely from 0 to 9, I know that there are total 10 columns, but because my syntax, I know that it will exclude 9th column, so it will go from 0 to 8, right? So I have extracted the features like this. Features are extracted, labels are extracted. Labels, so we know that last column is label. Dot values I'm putting so that indexing is not there, right? So this is the method for extraction. Then we will go for training set and test set. Train test split, again, same same method is required. Train test split. Again, we have taken 20% data. Now, what is random state? This is optional. You can omit it also. Random state says randomly, because every time you will execute this program, right? Every time you will have this model implemented, it will take different set for training, different set for testing. It may happen that first time when you implemented it, when you deployed it, testing data, whatever testing data it had, altogether it has gone to training set for the next time, and training data has come to the testing data, right? It may happen. I want same output to be there, right? I want to check it, I want to deploy it properly, I want to see for the same. So random state is 0 internally. It will not do any random selection, right? So this is optional feature. You may omit it, you may keep it, right? After that, another thing. Now, if you observe this data set, one more concept, let us understand, and then maybe after the break, we will implement it. In this thing, you can see clearly that first feature is of 3 digits, right? 114, 132, 206. Second feature is of maximum 2 digits. It may be in the points, and points maybe it can be in the, second place of decimal also, right? Third feature again single, fourth feature again double, 2 digits, 1 digit, 2 digit. So there is one feature that is actually having 3 digits. What is the problem? Now, our machine learning models, actually they work on number of digits. They do not know, definitely they do not know what does it mean. They don't know what does V1 means, what does V2 means, which one is more important. They gives priority to the features on the basis of number of digits. Very, very important point to be noted, right? Number of digits are very, very important, right? So priority of feature is dependent on this number of digits. Now, if I have given priority to this V1 feature, though it was not very important, right? So what I'm required to do scaling of features, right? Another term, scaling of feature, and that is called feature scaling, and that is also in the part of pre-processing, right? So sometimes whenever you have more than, your data is not properly symmetric data, right? It is somewhere it is 3 digits, somewhere it is less than 1 digit also, right? So you are required to have feature scaling. Fine. So we are required to have feature scaling. Now, how does this feature scaling happens? In case of this machine learning, feature scaling can also happen in various ways, right? The one way that what we are talking about is, which is taken, for example, the first feature is V1 parameter, and second feature is V2 parameter, and so on. Say V1 has 2, 3, 10, 12, 6, and V2 has some values 100, 200, 300, 250, 150, right? What I am required to do for feature scaling, I would take the mean of both, right? Mean of first column M1, mean of second column M2. I would take standard deviation of both. Is standard deviation, I hope we know that, how much deviated it is from mean. So we calculate M1, we calculate M2, we calculate SD1, we calculate SD2. After that, from every value of column 1, with every value of column 1, what I'm going to do, I'll subtract the mean value and divide it with standard deviation. So this is V1 column key first value. Second value would become 3 minus M1 divided by STD1. Next value would become 10 minus M1 divided by STD1. Next value will become 12 minus M1 by STD1. And the last value would become 6 minus M1 by STD1. This process would be done for every column. For V2 also, same thing, 100 minus mean of second column, because this is second column, divided by SD2. 200 minus M2 divided by SD2. 300 minus M2 divided by SD2. And similarly for all the columns. Right? Correct? After this, we will, a few values would be negative also, and few values would be positive also. But they would be in symmetry because they have been scaled, right? So to do that feature scaling, we have taken mean of every column. We have taken standard deviation of every column. We did these calculations from every value. And after that, if you check now, you will find that mean of every column would be 0 and standard deviation of every column would be 1, right? Okay. So this is how the processing for feature scaling would happen. But definitely Python mein you are not required to do all these things, right? What we are required to do, we are required to do just these 4 things. The concept is that I told you. For feature scaling, why we require feature scaling? I must know that. Where I should apply it, whenever I have a substantial difference between the number of digits. Why it is required? Because machine learning always takes into account number of digits as the priority element. So if number of digits are more, then this means this is more valuable. This feature is more valuable to us, and it may cause error, or it may give us wrong prediction, right? So that's why feature scaling is required. For feature scaling, all the columns we have noted, we have taken the mean of every column, we have taken the standard deviation of every column. After that, did some calculations and found that mean of every column is 0, standard deviation of every column is 1. Internally, this is the process, but in Python, we would be writing these lines which says sklearn say you're required to import the standard scalar. Again, you're required to have a constructor, required to have a fit transform method, required to have a transform method for test data, right? And then this would be done. So this is also pre-processing part. So in this thing, we have seen in pre-processing, we have done many things. One is importing data set. Second was extracting features. Third was extracting labels. Then we did fourth number pe train test split, and then we did feature scaling. So total 5 things, right? Now moving to the next says we are required to fit it. Obviously, import nothing else. From sklearn, import logistic regression, constructor. After that, fit for training data only, features train and labels train. And after that, predict. After prediction, we can check what my model says, right? We can have comparison between predicted value and test value. For that, I had a data frame, एक मैट्रिक्स ही बना दिया है, data frame ही बना दिया है. उसमें I can compare it properly, whether the predicted value or test case की value, whether this is coming, I mean, whether they are same or not, whether they are near to each other or not, right? After that, I can, this have been printed to just calculate the results. And then we move to confusion matrix, that is the performance metric. Till now, any doubt?
No doubt, ma'am.
So classification, maybe we can start after the break.
Yes,
Can we take
surely.
the break? And a confusion
Yes, ma'am.
matrix in between, I will
Surely.
move, right? Right. So see
Thank
you
you so
all
much,
after
ma'am.
the break. Thank you.
Thank you so much for the session, ma'am. Very informative, and yes, when doing it, learned so many things at the moment. Thank you for the session. Let's all meet after a short break at 2 o'clock. Okay, ma'am. Thank you.
Thank you.
Thank you. Sir, do you have any doubt? Vipin, sir? Vipin, sir, do you have any doubt? I have allowed the mic for you. Within the ma'am, I am allowing the mic. Yes, ma'am, any doubt? You can switch on the mic.
Yes. Yes, ma'am. Actually, I
Yes.
wanted to ask, ma'am, will you discuss the codes in case we are doing the train test split over here? Can you also help with the code where we have two separate files to be used as train and test?
Ma'am, actually the speaker is not there at the moment. This is the organizer, Sonia Batra. Okay. As we start the session, I'll just allow you with the mic, and when ma'am joins, you can put up your query at that moment. Okay. At 2
Okay,
o'clock.
thank you so much.
Okay, ma'am. Thank you so much.
Okay.
Bipin sir, at 2 o'clock, whatever query you can have, I'll let you with your mic and you can switch it on and ask the speaker for the day. Thank you so much, everyone. We'll all join back at 2 o'clock after the short break.